Gasoline, ʻɡæsəliːn, also known as petrol, outside North America, is a transparent, petroleum-derived liquid that is used primarily as a fuel in internal combustion engines. It consists mostly of organic compounds obtained by the fractional distillation of petroleum, enhanced with a variety of additives. On average, a 42-gallon barrel of crude oil yields about 19 US gallons of gasoline when processed in an oil refinery, though this can and does vary based on the crude oil source's assay. The characteristic of a particular gasoline blend to resist igniting too early is measured by its octane rating. Gasoline is produced in several grades of octane rating. Tetraethyllead and other lead compounds are no longer used in most areas to regulate and increase octane rating, but many other additives are put into gasoline to improve its chemical stability, control corrosiveness and provide fuel system cleaning, and determine performance characteristics under intended use. Sometimes, gasoline also contains ethanol as an alternative fuel, for economic or environmental reasons. Gasoline, as used worldwide in the vast number of internal combustion engines used in transport and industry, has a significant impact on the environment, both in local effects and in global effects. Gasoline may also enter the environment uncombusted, as liquid and as vapors, from leakage and handling during production, transport and delivery, from storage tanks, from spills, etc. As an example of efforts to control such leakage, many storage tanks are required to have extensive measures in place to detect and prevent such leaks. Gasoline contains benzene and other known carcinogens. History. The first automotive combustion engines, so-called Otto engines, were developed in the last quarter of the 19th century in Germany. The fuel was a relatively volatile hydrocarbon obtained from coal gas. With a boiling point near 85 degrees Celsius, it was well suited for early carburetors. The development of a spray nozzle carburetor enabled the use of less volatile fuels. Further improvements in engine efficiency were attempted at higher compression ratios, but early attempts were blocked by knocking. In the 1920s, anti-knock compounds were introduced by Thomas Midgley, Jr. and Boyd, specifically tetraethyllead. This innovation started a cycle of improvements in fuel efficiency that coincided with the large-scale development of oil refining to provide more products in the boiling range of gasoline. In the 1950s, oil refineries started to focus on high-octane fuels, and then detergents were added to gasoline to clean the jets in carburetors. The 1970s witnessed greater attention to the environmental consequences of burning gasoline. These considerations led to the phasing out of TEL and its replacement by other anti-knock compounds. Subsequently, low-sulfur gasoline was introduced, in part to preserve the catalysts in modern exhaust systems. Etymology and terminology. Gasoline is cited from 1863 in the Oxford English Dictionary. It was never a trademark, although it may have been derived from older trademarks such as ʻɡæsəliːn and ʻɡæsəliːn. Variant spellings of gasoline have been used to refer to raw petroleum since the 16th century. Petrol was first used as the name of a refined petroleum product around 1870 by British wholesaler Carlos Leonard, who marketed it as a solvent. When the product later found a new use as a motor fuel, Frederick Sims, an associate of Gottlieb Daimler, suggested to Carlos that they register the trademark petrol, but by this time the word was already in general use, possibly inspired by the French petrol, and the registration was not allowed. Carlos registered a number of alternative names for the product, while the competitors used the term motor spirit until the 1930s. The use of the word gasoline instead of petrol outside North America can often be confusing. Shortening gasoline to gas, which happens often, causes confusion with various forms of gas used as car fuel: liquefied natural gas and liquefied petroleum gas. In many countries, gasoline has a colloquial name derived from that of the chemical benzene. Argentina, Uruguay, Paraguay and Italy use the colloquial name naphtha derived from that of the chemical naphtha. Octane rating. Spark ignition engines are designed to burn gasoline in a controlled process called deflagration. However, the unburned mixture may auto-ignite by detonating from pressure and heat alone, rather than ignite from the spark plug at exactly the right time. This causes a rapid pressure rise which can damage the engine. This is often referred to as engine knocking or end gas knock. Knocking can be reduced by increasing the gasoline's resistance to auto-ignition, which is expressed by its octane rating. Octane rating is measured relative to a mixture of 2,4-trimethylpentane and N-heptane. There are different conventions for expressing octane ratings, so the same physical fuel may have several different octane ratings based on the measure used. One of the best known is the research octane number. The octane rating of typical commercially available gasoline varies by country. In Finland, Sweden, and Norway, 95 RON is the standard for regular unleaded gasoline, and 98 RON is also available as a more expensive option. In the UK, ordinary regular unleaded gasoline is 95 RON, premium unleaded gasoline is always 97 RON, and super unleaded is usually 97-98 RON. However, both Shell and BP produce fuel at 102 RON for cars with high-performance engines, and in 2006 the supermarket chain Tesco began to sell super unleaded gasoline rated at 99 RON. In the US, octane ratings in unleaded fuels can vary between 85 and 87 ARCI for regular, through 8990 ARCI for mid-grade, up to 9094 ARCI for premium. South Africa's largest city, Johannesburg, is located on the high veld at 1,753 meters above sea level, so the South African AA recommends 95 octane gasoline at low altitude and 93 octane for use in Johannesburg, because the higher the altitude, the lower the air pressure, and the lower the need for a high-octane fuel, as there is no real performance gain. The octane rating became important as the military sought higher output for aircraft engines in the late 1930s and the 1940s. A higher octane rating allows a higher compression ratio, a supercharger boost, and thus high temperatures and pressures, which translate to higher power output. Some scientists even predicted that a nation with a good supply of high-octane gasoline would have the advantage in air power. In 1943, the Rolls-Royce Merlin aero engine produced 1,320 horsepower using 100 RON fuel from a modest 27-liter displacement. By the time of Operation Overlord during World War II, both the RAF and USAAF were conducting some operations in Europe using 150 RON fuel, obtained by adding 2.5% aniline to 100 octane of gas. By this time, the Rolls-Royce Merlin 66 was developing 2,000 horsepower using this fuel. Stability. Quality gasoline should be stable for 6 months if stored properly, but gasoline will break down slowly over time due to the separation of the components. Gasoline stored for a year will most likely be able to be burned in an internal combustion engine without too much trouble, but the effects of long-term storage will become more noticeable with each passing month, until a time comes when the gasoline should be diluted with ever-increasing amounts of freshly made fuel so that the older gasoline may be used up. If left undiluted, improper operation will occur, and this may include engine damage from misfiring and/or the lack of proper action of the fuel within a fuel injection system and from an onboard computer attempting to compensate. Storage should be in an airtight container that can withstand the vapor pressure of the gasoline without venting at a stable cool temperature. When gasoline is not stored correctly, gums and solids may be created, which can corrode system components and accumulate on wetted surfaces, resulting in a condition called stale fuel. Gasoline containing ethanol is especially subject to absorbing atmospheric moisture, then forming gums, solids, or two phases. The presence of these degradation products in the fuel tank, fuel lines plus a carburetor fuel injection components makes it harder to start the engine and causes reduced engine performance. On resumption of regular engine use, the buildup may or may not be eventually cleaned out by the flow of fresh gasoline. The addition of a fuel stabilizer to gasoline can extend the life of fuel that is not or cannot be stored properly, though removal of all fuel from a fuel system is the only real solution to the problem of long-term storage of an engine or a machine or vehicle. Some typical fuel stabilizers are proprietary mixtures containing mineral spirits, isopropyl alcohol, 1,2,4-trimethylbenzene, or other additives. Fuel stabilizer is commonly used for small engines, such as lawn-mower and tractor engines, especially when the use is seasonal. Users have been advised to keep gasoline containers more than half full and properly capped to reduce air exposure, to avoid storage at high temperatures, to run an engine for 10 minutes to circulate the stabilizer through all components prior to storage, and to run the engine at intervals to purge stale fuel from the carburetor. Gasoline stability requirements are set in standard ASTM D481414B. The standard describes the various characteristics and requirements of automotive fuels for use over a wide range of operating conditions in ground vehicles equipped with spark ignition engines. Energy content. Energy is obtained from the combustion of gasoline by the conversion of a hydrocarbon to carbon dioxide and water. The combustion of octane follows this reaction. 2C8H18 plus 25O2 16CO2 plus 18H2O. Gasoline contains about 42.4 megajoules per kilogram, quoting the lower heating value. Gasoline blends differ, and therefore actual energy content varies according to the season and produce by up to 4% more or less than the average. According to the US EPA, on average, about 74 L of gasoline are available from a barrel of crude oil, varying due to quality of crude and grade of gasoline. The remainder are products ranging from tar to naphtha. A high-octane rated fuel, such as liquefied petroleum gas, has an overall lower power output at the typical 10:1 compression ratio of a gasoline engine. However, with an engine tuned to the use of LPG, the power output can be improved. This is because higher octane fuels allow for a higher compression ratio without knocking, resulting in a higher cylinder temperature, which improves efficiency. Also, increased mechanical efficiency is created by a higher compression ratio through the concomitant higher expansion ratio on the power stroke, which is by far the greater effect. The higher expansion ratio extracts more work from the high-pressure gas created by the combustion process. An Atkinson cycle engine uses the timing of the valve events to produce the benefits of a high expansion ratio without the disadvantages, chiefly detonation, of a high compression ratio. A high expansion ratio is also one of the two key reasons for the efficiency of diesel engines, along with the elimination of pumping losses due to throttling of the intake airflow. The low energy content of LPG in comparison to gasoline is due mainly to its lower density. Energy content per kilogram is higher than for gasoline. Molecular weights of the above reagents are C8H18 O232, CO244, H2O18. Therefore 1 kilogram of fuel reacts with 3.51 kilograms of oxygen to produce 3.09 kilograms of carbon dioxide and 1.42 kilograms of water. Density. The density of gasoline ranges from 0.71 to 0.77 kg/L, higher densities having a greater volume of aromatics. Since gasoline floats on water, water cannot generally be used to extinguish a gasoline fire unless used in a fine mist. Finished marketable gasoline is traded with a standard reference of 0.755 kg/L, and its price is escalated according to its actual density. Chemical analysis and production. Gasoline is produced in oil refineries. Roughly 19 US gallons of gasoline is derived from a 42-gallon barrel of crude oil. Material separated from crude oil via distillation, called virgin or straight-run gasoline, does not meet specifications for modern engines, but can be pooled to the gasoline blend. The bulk of a typical gasoline consists of hydrocarbons with between 4 and 12 carbon atoms per molecule. It is a mixture of paraffins, cycloalkanes, and olefins, where the usage of the terms paraffin and olefin is particular to the oil industry. The actual ratio depends on the oil refinery that makes the gasoline, as not all refineries have the same set of processing units. The crude oil feed used by the refinery. The grade of gasoline, in particular, the octane rating. The various refinery streams blended to make gasoline have different characteristics. Some important streams are: straight-run gasoline, usually also called naphtha, is distilled directly from crude oil. Once the leading source of fuel, its low octane rating required lead additives. It is low in aromatics, containing some cycloalkanes and no olefins. Between 0 and 20% of this stream is pooled into the finished gasoline, because the supply of this fraction is insufficient and its run is too low. The chemical properties of the straight-run gasoline can be improved through reforming and isomerization. However, before feeding those units, the naphtha needs to be split in light and heavy naphtha. Straight-run gasoline can be also used as a feedstock into steam crackers to produce olefins. Reformate, produced in a catalytic reformer, has a high octane rating with high aromatic content and relatively low olefins. Most of the benzene, toluene, and xylene are more valuable as chemical feedstocks and thus removed to some extent. Catalytic cracked gasoline, a catalytic cracked naphtha, produced from a catalytic cracker with a moderate octane rating, high olefins content, a moderate aromatics level. Hydrocrackate, produced from a hydrocracker with medium to low octane rating and moderate aromatic levels. Alkylate is produced in an alkylation unit using as feedstocks isobutane and alkenes. Alkylate contains no aromatics and alkenes and has high mon. Isomerate is obtained by isomerizing low-octane straight-run gasoline to isoparaffins. Isomerate has medium ron and mon, but nil aromatics and olefins. Butane is usually blended in the gasoline pool, although the quantity of this stream is limited by the RVP specification. The terms above, the jargon used in the oil industry and terminology varies. Currently, many countries set limits on gasoline aromatics in general, benzene in particular, and olefin content. Such regulations led to increasing preference for high-octane pure paraffin components, such as alkylate, and is forcing refineries to add processing units to reduce benzene content. In the EU, the benzene limit is set at 1% volume for all grade of automotive gasoline. Gasoline can also contain other organic compounds, such as organic ethers, plus small levels of contaminants, in particular organosulfur compounds, but these are usually removed at the refinery. Additives. Inhaled gasoline vapor is a common intoxicant that has become epidemic in some poorer communities and indigenous groups in Australia, Canada, New Zealand, and some Pacific islands. In response, opal fuel has been developed by the BP Kwinana refinery in Australia and contains only 5% aromatics, which weakens the effects of inhalation. Anti-knock additives. Almost all countries in the world have phased out automotive leaded fuel. In 2011, 6 countries in the world were still using leaded gasoline: Afghanistan, Myanmar, North Korea, Algeria, Iraq and Yemen. It was expected that by the end of 2013, those countries would ban leaded gasoline, but it has not occurred. Algeria will replace leaded with unleaded automotive fuel only in 2015. Different additives have replaced the lead compounds. The most popular additives include aromatic hydrocarbons, ethers and alcohol. For technical reasons, the use of leaded additives is still permitted worldwide for the formulation of some grades of aviation gasoline such as 100LL, because the required octane rating would be technically infeasible to reach without the use of leaded additives. Tetraethyllead gasoline, when used in high-compression internal combustion engines, tends to auto-ignite, causing damaging, engine-knocking noise. To address this problem, tetraethyllead was widely adopted as an additive for gasoline in the 1920s. With the discovery of the extent of environmental and health damage caused by the lead, however, and the incompatibility of lead with catalytic converters, leaded gasoline was phased out in the USA beginning in 1973. By 1995, leaded fuel accounted for only 0.6% of total gasoline sales and under 2,000 short tons of lead per year in the USA. For the 1st of January 1996, the U.S. Clean Air Act banned the sale of leaded fuel for use in on-road vehicles in the USA. The use of TEL also necessitated other additives, such as dibromoethane. First European countries started replacing lead by the end of the 1980s, and by the end of the 1990s leaded gasoline was banned within the entire European Union. Reduction in the average blood lead level is believed to have been a major cause for falling violent crime rates in the United States and South Africa. A statistically significant correlation has been found between the usage rate of leaded gasoline and violent crime. Taking into account a 22-year time lag, the violent crime curve virtually tracks the lead exposure curve. MMT-methylcyclopentadienyl manganese tricarbonyl is used in Canada and in Australia to boost octane. It also helps old cars designed for leaded fuel run on unleaded fuel without need for additives to prevent valve problems. Its use in the US has been restricted by regulations. Fuel stabilizes. Gummy, sticky resin deposits result from oxidative degradation of gasoline upon long-term storage. These harmful deposits arise from the oxidation of alkenes and other minor components in gasoline. Improvements in refinery techniques have generally reduced the susceptibility of gasolines to these problems. Previously, catalytically or thermally cracked gasolines are most susceptible to oxidation. The formation of these gums is accelerated by copper salts, which can be neutralized by additives called metal deactivators. factors. This degradation can be prevented through the addition of 5 to 100 ppm of antioxidants, such as phenylenediamines and other amines. Hydrocarbons with a bromine number of 10 or above can be protected with the combination of unhindered or partially hindered phenols and oil-soluble, strong amine bases, such as hindered phenols. Stale gasoline can be detected by a colorimetric enzymatic test for organic peroxides produced by oxidation of the gasoline. Gasolines are also treated with metal deactivators, which are compounds that sequester metal salts that otherwise accelerate the formation of gummy residues. The metal impurities might arise from the engine itself or as contaminants in the fuel. Detergents. Gasoline, as delivered at the pump, also contains additives to reduce internal engine carbon buildups, improve combustion, and to allow easier starting in cold climates. High levels of detergent can be found in top-tier detergent gasolines. The specification for top-tier detergent gasolines was developed by 4 automakers: GM, Honda, Toyota and BMW. According to the bulletin, the minimal EPA requirement is not sufficient to keep engines clean. Typical detergents include alkylamines and alkyl phosphates at the level of 50 to 100 ppm. Ethanol. European Union. In the EU, 5% ethanol can be added within the common gasoline spec. Discussions are ongoing to allow 10% blending of ethanol. In Finland, most gasoline stations sell 95E10, which is 10% of ethanol, and 985, which is 5% ethanol. Most gasoline sold in Sweden has 5 to 15% ethanol added. Brazil. In Brazil, the Brazilian National Agency of Petroleum, Natural Gas and Biofuels requires gasoline for automobile use to have 27.5% of ethanol added to its composition. Pure hydrated ethanol is also available as a fuel. Australia legislation requires retailers to label fuels containing ethanol on the dispenser, and limits ethanol use to 10% of gasoline in Australia. Such gasoline is commonly called E10 by major brands, and it is cheaper than regular unleaded gasoline. United States. The Federal Renewable Fuels Standard effectively requires refiners and blenders to blend renewable biofuels with gasoline, sufficient to meet the growing annual target of total gallons blended, although the mandate does not require a specific percentage of ethanol. Annual increases in the target combined with declining gasoline consumption has caused the typical ethanol content in gasoline to approach 10%. Most fuel pumps display a sticker that states that the fuel may contain up to 10% ethanol, an intentional disparity that reflects the varying actual percentage. Until late 2010, fuels retailers were only authorized to sell fuel containing up to 10% ethanol, and most vehicle warranties authorize fuels that contain no more than 10% ethanol. In parts of the United States, ethanol is sometimes added to gasoline without an indication that it is a component. India. The government of India in October 2007 decided to make 5% ethanol blending mandatory. Currently, 10% ethanol blended product is being sold in various parts of the country. Ethanol has been found in at least one study to damage catalytic converters. Dye. In Australia, the lowest grade of gasoline is dyed a light shade of red, orange, and the medium grade is dyed yellow. In the United States, aviation gasoline is dyed to identify its octane rating and to distinguish it from kerosene-based jet fuel, which is clear. In Canada, the gasoline for marine and farm use is dyed red and is not subject to road tax. Oxygenate blending. Oxygenate blending adds oxygen-bearing compounds such as MTBE, ETBE, ethanol, and biobutanol. The presence of these oxygenates reduces the amount of carbon monoxide and unburned fuel in the exhaust gas. In many areas throughout the U.S., oxygenate blending is mandated by EPA regulations to reduce smog and other airborne pollutants. For example, in Southern California, fuel must contain 2% oxygen by weight, resulting in a mixture of 5.6% ethanol in gasoline. The resulting fuel is often known as reformulated gasoline or oxygenated gasoline, or in the case of California, California reformulated gasoline. The federal requirement that RFG contain oxygen was dropped on 6 May 2006 because the industry had developed VOC-controlled RFG that did not need additional oxygen. MTBE was phased out in the U.S. due to groundwater contamination and the resulting regulations and lawsuits. Ethanol and, to a lesser extent, the ethanol-derived ETBE are common replacements. A common ethanol-gasoline mix of 10% ethanol mixed with gasoline is called gasohol or E10, and an ethanol-gasoline mix of 85% ethanol mixed with gasoline is called E85. The most extensive use of ethanol takes place in Brazil, where the ethanol is derived from sugarcane. In 2004, over 3.4 billion U.S. gallons of ethanol was produced in the United States for fuel use, mostly from corn, and E85 is slowly becoming available in much of the United States. Though many of the relatively few stations vending E85 are not open to the general public, the use of bioethanol, either directly or indirectly by conversion of such ethanol to bio-ETBE, is encouraged by the European Union Directive on the Promotion of the Use of Biofuels and Other Renewable Fuels for Transport. Since producing bioethanol from fermented sugars and starches involves distillation, though, ordinary people in much of Europe cannot legally ferment and distill their own bioethanol at present.